So right now we're going to be talking about classifying matter. So we've been talking about matter and what it is, but right now we're going to break it down and tell you the difference between elements, compounds, and mixtures. So remember those because these come in heavy on the midterm and even the final. The final is comprehensive, so that just means the things that you see in the midterm you can see again in the final, and these will definitely be on both. So remember, matter is anything that has mass and takes up space, right? Pretty much everything in this universe is matter, except for mostly like energy. And we'll talk about that later still. All right. So when you're breaking down matter, this is what we're talking about, breaking it down into the purest, most simplest forms, right? So when you're breaking down matter and just trying to make it into its simplest forms, you got to ask yourself two questions. Variable composition means, is it made up of a pure substance or is it made up of a mixture of things? And so if it's not made up of different things, then your answer is no, and you go into the pure substances. If your answer is yes, and it is made up of many different things, then you go into the mixtures. So we'll go to the left first for pure substances. If something is a pure substance, then you have to ask yourself, can you break it up into anything simpler than that? Right? And if the answer is no, you can't break it down anymore, then you have yourself an element. And these are the things that are on the periodic table that we have here in the classroom. And I'll post actually in the class, the Google Classroom soon. Element is just its purest form. So things like oxygen and carbon and nitrogen, and here you see helium, but gold and platinum and silver, those are the simplest, purest forms of that thing, of that piece of matter. And that's an element. That's as pure as you can get is an element. All right. So if you're talking about pure substances and your answer is it can be broken, yes, it can be broken into simpler substances, and you have yourself a compound. And in this case right here, we see those little Mickey Mouse heads, right? The red oxygen and the two white hydrogens. That's H2O. That's pure water. Every single one of those molecules, so every one of those little Mickey Mouse heads is called a molecule. And this molecule is made up of two or more different atoms, right? It's made up of H and O, hydrogen and oxygen. And so it's made up of two different atoms. But if you look at that, the reason why it's a pure substance is because, and our compound is because every single molecule in there is a water molecule. It's all just pure H2O molecules, right? That you see there. All right, and we're going to talk more about this. So if you don't understand it, that's okay. We'll talk into more detail about this. And then we go over to the other side about the mixtures. So if you have a mixture, if it's uniform throughout, so it means it's the same throughout, then it is a homogeneous mixture. And there you see it on the right. A homogeneous mixture is just, homo means same, right? So if you're thinking about homogeneous mixture, it just means it's the same throughout. Everything is mixed evenly. So think of like a piece of or a drop of food coloring swirled around in water. That whole little container of water is going to turn that same color, right? Because it's evenly distributed throughout. Heterogeneous is different. It is not evenly distributed throughout. Hetero means different, so the mixture is different throughout. Think of like oil and water, right? When you mix oil and water, they really don't mix well together, right? So all the oil will sink to the bottom and all the water will float on top. That's what it is saying here is that it's not the same throughout. The water is on the top, the oil is on the bottom, and so it is different throughout.